In this video, I will explain how to draw the Lewis structures or the Lewis diagrams of atoms and molecules. I'm going to start by how you can draw the Lewis diagrams of atoms, because that is the starting point in this discussion. So let me write here Lewis structures. The most important thing that you need to know when you're drawing Lewis structures is the number of valence electrons. In other words, the number of electrons in the valence shell of an atom. What we call the valence shell of an atom is the outermost energy level or the outermost shell of an atom. For example, if I draw the atom of, let me say, sodium. So this is a sodium atom, and A representing sodium. This is a sodium atom. If I call this the nucleus, this is the nucleus of the sodium atom. And sodium is in group 1 and in period 2. Because it is in group 1 and period 3. Let me write that down. Not period 2, it's period 3. So sodium is in group 1 on the periodic table of elements, and it is in period 3. Period 3. What we call groups on the periodic table of elements are the vertical columns. We call them groups. Then the rows, the horizontal rows, we call them periods. So if we go to our periodic table of elements, we find sodium in group 1, which is the first column, and it is in period 3, which is essentially the third horizontal row, or the third row. Now, if you want to draw the atom of sodium, this information here is very critical. This information is very important. That is in group 1 and period 3. This is the information that you need when you are drawing a sodium atom. And then there is more information that you need. It is atomic number 11. On the periodic table of elements, sodium is number 11, which means it is atomic number 11. And this, when we say it is atomic number 11, from this information, we know something. From the atomic number, we know that it is 11 protons. And because in an atom, the number of protons are equal to the number of electrons, we also know that sodium has 11 electrons. So sodium has 11 protons. It also has got 11 electrons. Now, with all this information, I can sketch the structure, or I can draw the structure of a sodium atom. So if I call this the nucleus, where we find protons and neutrons, we have three. I'm going to draw 3 circles here. Let me use this. I'm going to draw 3 circles. So this is going to be the first circle. Let me move it. Oh, all right. Let me draw the first circle here. All right. Let me just draw some rough circles. So this is going to be my first circle. Then I draw a second one and a third one. So I have 3 circles here. These 3 circles, I'm drawing them because I know it is in period 3. So if any element in period 3 will have 3 energy levels. So this is the sodium atom. It has 3 energy levels, but it has got 11 electrons. I'm going to distribute the electrons now. I'm going to use a different color. Let me use this color. Now, there will be 2 electrons in the first energy level. We count our energy levels from inside out. So in the first energy level, we have got 2 electrons, and in the second energy level, we have 8 electrons. And in the third energy level, we have got 1 electron if it is a sodium atom. This last electron, it is in what we call the valence shell. So let me label this as our valence shell. We call this the valence shell. The valence shell is the outermost energy level of an atom. So in this case, the sodium atom, the outermost energy level has got 1 electron, and that is the valence shell. Now, when you are drawing Lewis structures, you don't worry or you don't care about these other electrons in the what we call the core shells. So these are the core shells. Let me label them. So this one here and this one, both of them are what we call the core shells. The inner shells, we call them the core shells, and the electrons in there, we call them the core electrons. So those are core electrons. We don't care. There's a reason for this. The reason is that for whenever we are having chemical reactions, we don't care about, in fact, the core electrons are not involved in chemical reactions. When there's a chemical reaction, it is only the transfer or the sharing of the valence electrons. That is what we're worried about. See, so when you're drawing Lewis structures, you are just worried about the valence shell and the electrons in the valence shell, or what we call the valence electrons. It is a very important part. It's a very important thing for you to understand, that when you're drawing Lewis structures, you're only worried about the valence electrons, which are essentially electrons in the valence shell, which means electrons in the outermost energy level. That's it. Now, how do you know how many electrons are in the valence shell? The group number tells you. In this case, sodium is in group 1. It has got 1 valence electron. All the elements in group 1, from lithium to sodium to potassium, they all have got 1 valence electron. Same, if you go to group 2, all the elements in there, like beryllium, like calcium, like barium, and magnesium, they all have got 2 valence electrons. If you go to group 3, where we have got boron, where we have got aluminium, they have 3 valence electrons. If you go to group 8, which are the noble gases, they have 8 valence electrons. Group 7, the halogens, the chlorines, fluorine, bromine, and iodine, they have got 7 valence electrons. So it is quite easy for you to know where you get the number of valence electrons. You just go to your periodic table of elements. It gives you that. So let me write this down, and you please write it down and also put it in your mind that when drawing Lewis structures, Lewis structures, you need to know number of valence electrons. So we need to know the number of valence electrons. This is key. We need to know that. And here we use what? How do we know the number of valence electrons? We rely on the group number. The group number indicates the number of valence electrons. Simple. Indicate the number of valence electrons. So there's no one who should say, I don't know, or I'm struggling to find out how many valence electrons does carbon have. You just go to your periodic table of elements, check the group number where you find carbon. If it is in group 4, where it is, by the way, it means carbon has got 4 valence electrons. If you want to know the number of valence electrons for iodine, you simply go to your periodic table of elements, check where you find iodine, which group it is. You'll find that it's in group 7, and that tells you that iodine has got 7 valence electrons. That's it. See? So it tells you the number of valence electrons. We're done with that. The other thing that you need to know when you're drawing Lewis structures, the second thing, is the symbol. What we call, let me call it the chemical symbol. So this is the chemical symbol of the element. Chemical symbol of the element. This requires you to know your periodic table of elements, and if you have got your periodic table of elements and it has names, obviously you know that if you see Cl, it is chlorine. See, Cl is for chlorine, and O is for oxygen, N is for nitrogen, Pb is for lead, C is for carbon, and Al is for aluminium, and Na is for sodium. You need to know the symbols of the of all the elements on the periodic table of elements. You should know the symbols. That is what you need when you're drawing a Lewis diagram. You need to know the number of valence electrons, and you need to know the chemical symbol. Once you know these two, you can draw the Lewis structures. Now let me go to the drawing of the Lewis structures itself. Okay, I'm going to start with atoms. So Lewis structures for atoms. If I want to draw the Lewis structure of an atom, I first write the symbol, the chemical symbol of that atom. Now let me use a different pen. Check this one. If it is carbon, I will write a C for carbon. So this is C representing carbon, which is, this is the chemical symbol of carbon. I write that first. Then I use a dot or crosses to indicate the electrons. How many electrons are in the valence shell of carbon? It's 4. So this is carbon. I'm just going to write something here. It is 4 valence electrons. So it is 4 valence electrons. I know this because I have a periodic table of elements. I went there and I saw that carbon is in group 4, so it has 4 valence electrons. The group number indicates the number of valence electrons. Then chemical symbol is C. That this is the symbol for carbon. I have it. Now let me put my electrons. We usually write 4, 1, 2, 3, 4. When we're drawing Lewis structures, we put 4 around the symbol without pairing them. After that, we start pairing. So if we have got 4 like here, we just put them singly. 1, 2, 3, 4. And we leave it like that without pairing anything. So this is the Lewis structure of carbon. Let me write for another. So this is for carbon. Let me label that. So this is our carbon. If someone says to you, draw the Lewis structure of carbon, this is what you draw. And let me draw for nitrogen. I put in N. Nitrogen is in group 5. So it is 5 valence electrons. Let me indicate them. I will first put 4 around. The fifth one, I have to pair it with one of these. It doesn't matter which one. So this is the Lewis structure of a nitrogen. I could have paired it with this one here or this one. It doesn't matter really, but you should just write them like this. And this is nitrogen. So this is the Lewis structure of nitrogen. You see what I have here on the Lewis structure? I just have got two things for my Lewis structure. I have, let me use a different pen to just indicate this. This one here is my chemical symbol. I also get it from the periodic table elements. And these ones, the five things, these ones, all of them, these are the valence electrons. So these are valence electrons. See? So on my Lewis diagram, I just have the chemical symbol and the valence electrons. I'm done. If I want to do the same for oxygen, let me draw for oxygen. The symbol for oxygen is an O. I draw the O, and I know that oxygen is in group 6. Therefore, it has 6 valence electrons. Let me indicate the electrons. We said we put 4 around singly, then we pair. So this is my Lewis diagram for oxygen. It's done. Or the symbol is there, and the 6 valence electrons are shown. Which other element? Let me go to boron. No, not boron. Bromine. Bromine. Br is the symbol. So Br is my symbol for bromine. I go to my periodic table and look for bromine. I find this in group 7. So this is in group 7. It tells me that it is 7 valence electrons. So I'll just have to put 7 valence electrons here. All right, let me do it step by step. I said put 4 singly around, then start pairing. This is the Lewis structure of bromine. So this is bromine Lewis structure. That is it. I hope everyone gets it right, and it's quite a straightforward issue. Just know the symbol of the element and also know the group number, because it is an indicator of the number of valence electrons. On our Lewis diagram, we just need the symbol and the valence electrons. So once we know how to draw the Lewis structures of atoms, by the way, we can now go to the molecules. What we call a molecule, so this is the Lewis structure, Lewis diagram. Let me just put it Lewis diagram for molecules. What we call a molecule is 2 or more atoms chemically bonded. We call that a molecule. Obviously covalently bonded, by the way. Molecules are only covalently bonded, which means electrons are being shared in a molecule. So I'm going to show you how you draw the Lewis diagram of molecules. All you need to know is when you're drawing the Lewis diagram of a molecule, you need to know one. Here, you need to know what we call the central atom. You need to know the central atom, and also the valence electrons here of the central atom. Valence electrons, you need to know that. Okay, and the other atoms that I'll call them the peripheral atoms. The peripheral atoms. These are the atoms surrounding the central atom, and they also have got valence electrons. Obviously, valence electrons. Okay, you may also need to know the number of bonds. Number of bonds. Most of these things, you end up knowing them through experience. Later, if you ask me to draw the Lewis structure of, let's say, methane or oxygen or hydrogen, whatever it is, I don't take time because I know it from experience. So with practice, you end up having this experience and you can easily draw the Lewis diagram. Let me start here with an example, and I'm going to use methane. So when you're drawing a Lewis, maybe I should add here that the other thing that you should know is let me add here, you need to know the chemical formula. Chemical formula of that molecule. You need to know the chemical formula. It is very important that you know the chemical formula. So let's start. I said my first example would be methane. So Lewis diagram of methane. Methane. All right. Methane. The chemical formula for methane is CH4. CH4. From here, I can see from the formula that I have 1 carbon atom and 4 hydrogen atoms. Now, I have to know which one is the central atom and which ones are the peripheral atoms. In this case, carbon is our central atom. So this is the central atom. And the hydrogens are our peripheral atoms. So these are in the periphery. These are our peripheral atoms, or the atoms surrounding the central atom. It's hydrogen. It is quite easy to know which one is the central atom and which one is the peripheral one. The central atom is usually the atom that can form the largest number of bonds. Hydrogen can only form 1 bond, whereas carbon can form 4 bonds. So from there, you know that carbon is the central atom. So I'm going to write my central atom first. Let me use a blue color. So here is my central atom, carbon. It has, let me write it down here. It has 4 valence electrons. So let me add the valence electrons of carbon. I'm going to use a green pen. So these are the 4 valence electrons of carbon. When we are forming methane, we have 4 hydrogen atoms. This, as we said a molecule is covalently bonded, which involves the sharing of electrons. So let me use a different color for hydrogen. This is hydrogen, H. So we have 4 of them. One of them comes here, H. I am assuming you guys already understand covalent bonding, and it brings along 1 electron. I'm going to use this color for the electron being contributed by a hydrogen. Another hydrogen atom comes here. It brings it. Another one comes here. Another one comes here. Now, if you look at the diagram that I have now, around the carbon atom, we now have got 8 electrons. So whereas initially carbon had 4 valence electrons, now it has got 8. And this is the reason for bonding. I'm just going to go off topic a little bit here. This is the reason for bonding. When atoms bond with other atoms, the aim there is to form stable structures, stable electronic structures. Why are they doing this? They want to be like the noble gases, which are in group H. All the noble gases have got 8 valence electrons. So carbon here is now having 8 electrons. It is now imitated, or it is now appearing like the noble gases, and that is what brings stability in nature. And that is why we have atoms bonding with other atoms to just create these structures that are stable, more stable than the atom itself. That is what we have. And if we go to the hydrogen here, it now has got 2 valence electrons, and it is fine. That is the maximum that it can take. Remember, hydrogen is in period 1. It can only have 2 electrons in its valence shell. So it is fine now. It has all those 2 electrons. Now, so this is the Lewis diagram of methane. So Lewis diagrams are also called, we call them dot and cross structures. Dot and cross. This dot and cross, the dot and the crosses are used to indicate electrons. So you can indicate your electrons using dots. So you may find some Lewis structures, let's say for carbon, written like the C and with dots around the C, 4 dots. The dots are simply indicating the electrons. So we can either use dots or we use crosses. That is what we use for Lewis diagrams. All right. Let me do another example for hydrogen. Hydrogen. Lewis diagram for hydrogen. Lewis diagram for hydrogen. For hydrogen, I'm going to start by drawing the Lewis structures of each hydrogen atom. So hydrogen is H2, H2. I want to explain this part. There is what we call a hydrogen atom and a hydrogen molecule. This is a hydrogen molecule. H2 is a hydrogen molecule. This is a molecule. Hydrogen in nature is found as a diatomic molecule. It is a molecule with 2 atoms. So it's 2 hydrogen atoms chemically bonded or chemically combined. That is what we find in nature. But if we want to just focus on the hydrogen itself, atom, we'll have 1 hydrogen atom like this. It will be having 1 electron, which is the valence electron, and another hydrogen atom here. It also has got 1 valence electron. These hydrogen atoms on their own, they are not stable. To have stability, they need 2 valence electrons. And how do they do that? They share. So they come together. This one comes together with this one. They share these electrons, which is a covalent bond, what we call a covalent bond. I'm going to do another video where I explain chemical bonding, but then I'm just mentioning it here. So they come together. Now they're here and next to each other. And now they share these 2 electrons. So now this is now the Lewis structure of, or the Lewis diagram of hydrogen, the hydrogen molecule. That is it. I want to draw another one so this is just a single bond. This is just a single bond. That's a single bond. And then let me go to another very interesting one. This one is nitrogen. I'm going to do nitrogen. So nitrogen, the Lewis structure for nitrogen. It's quite challenging to many people. I'll start by drawing the nitrogen itself. The nitrogen atom. This is the nitrogen atom. It is in group 5, so it has 5 valence electrons. I'm going to just put them like this. Then this one is unpaired. So we have 2. So nitrogen is N2. This is how we find a nitrogen in nature. It is a diatomic molecule, so this is the nitrogen molecule. We want to draw the Lewis diagram of a nitrogen molecule. So this is one atom, and then let me draw for another one. So it will be also like this. Okay, we want stability here. So these two are going to come together and bond and form a molecule. This is what happens when they come together. So this will be an N and another N. These single electrons here, these ones, they are going to pair up, and then that is the sharing that is going to okay, they're going to pair up and form a triple bond. So this, we're going to have this one coming here and sharing. So they come here and then one and paired. All right, I'm just going to say something here. These ones in the middle, these are what we call bonding electrons. So these are bonding pairs. The ones that are shared, they're shared, they're bonding pairs. And these ones, we call them lone pairs. So these are lone pairs. I'm going to explain this further when I explain chemical bonding. But now we have achieved something. If you go to each nitrogen atom, you now see that around it, there are now 8 electrons, what we call an octet. I'm going to describe the octet in another video, but we now call it an octet. And we have nitrogen, just like this. So nitrogen has what we call a triple bond. This is a triple bond. 6 electrons that are being shared. We call this a triple bond because one bond is 2 electrons. So this one, and that one. So we've got 1, 2, 3 bonds here in the nitrogen molecule. 3 bonds. This is the reason why nitrogen is very stable or very inert, very unreactive. It is because of this triple bond. It's a very strong bond which makes it difficult to break, and nitrogen becomes a very stable bond. Okay, you can draw Lewis structures of ions, of molecules, of atoms. All you need to know is how many valence electrons do you have, and then you draw that. It is quite a straightforward issue. I think I've explained this clearly. If you have any questions or any further questions, just comment in the comment section below. I will respond to you, or I will do another video where I explain those things that maybe you are being confused about or that you need clarity on. Remember to subscribe to the channel and to like the videos and share it with your friends. Otherwise, thank you.